What is up, Flutter devs? In the previous video, we implemented keyboard input for our processing sketches, and today we're going to try to implement mouse input. Then we'll have keyboard and mouse, and we're pretty much good to go as far as input is concerned. So let's go look at the mouse APIs and see what it is that we need to do. Here's the standard API documentation for processing, and you will see here the mouse category. Under mouse, there's a mouse X and mouse Y. That represents the current X and Y value of the mouse at a given moment in time. And then this P mouse X, P mouse Y, that stands for previous. Previous X position, previous Y position. So you always have the current one and the one from the previous frame. Not sure what's special about just the previous one, but that's what processing does, so that's what we're going to do. Then we have a number of callbacks and a few properties. So we have a mouse button, that is what button was most recently pressed or released. And then mouse pressed is a Boolean, like is mouse pressed. And then we have callbacks. So when you press a button on the mouse, you get mouse pressed. When you release, you get mouse released. When you move, when no buttons are pressed, but you move the mouse, you get mouse moved. When you're holding down a button and you're moving the mouse, you get mouse dragged. Now, mouse clicked is interesting because it begs the question, what's the difference between mouse released and mouse clicked? It's somewhat minor. If you tap in the window and you release in the window, that's a click. But supposedly, I'm forgetting now what the precise situation is. It's something to do with whether you enter or leave the window of the application when you press down and release. So I think, actually, I think how it works is like this. If you tap and release within the window, that's a click. You get released and clicked. If you tap within the window, drag outside the window and release, you still get the released call, but you don't get the clicked call. I think for us at this juncture, I'm just going to invoke both of them all the time and worry sometime later about differentiating between them because it's not really worth dealing with whether you're in the window or out of the window. Maybe there's something obvious there, but I'm not sure off the top of my head how to do that, and it's not worth spending much time on it. Regardless, these are the things that we want to implement. Now, in this case, because we're dealing with a mouse, first of all, gestures are kind of a pain to test. There is some functionality for testing gestures, but it is kind of annoying. The second thing is that I'm not sure there's anything in the widget tester yet to test the movement of the mouse when there are no gestures. Because gestures always begin with tapping somewhere. But a hovering mouse, by definition, does not involve pressing any buttons. So I'm not sure there is any way to test that. So instead, we're not going to write any tests for this functionality. What we're going to do is build essentially an empty sketch in the demo app, and then we're going to have some print statements, and we're going to make sure that those print statements show us what we expect as we interact with the mouse, and we're going to use that as verification for what we're building. So unlike other exercises, we're not going to begin with tests. We're going to take mouse X, mouse Y, P mouse X, P mouse Y, and we're just going to jump right in and stick those where we think they belong. Here we are back in the code. We have the core file open, and this mouse behavior belongs right above the keyboard behavior. So let's go find some keyboard behavior. Here's the start input for keyboard. I'll copy this header. Now we'll do start input mouse. And I just said that we want mouse X, mouse Y, P mouse X, P mouse Y. And those are going to be integers, I think, from processing's perspective. We will have int mouse X, and I believe the processing documentation says that initially the value is 0. The default value of mouse X is 0. So before the mouse actually gets into the window, we default it to 0. Now that's a private variable because I only want our code to be able to change mouse X, but we do need to be able to query mouse X. So int get mouse X returns underscore mouse X. Do the same thing for mouse Y. And then the versions for previous values. And let me check the capitalization there. Okay, lowercase p, lowercase m. All right, those are the values. But then there were also, we want mouse pressed, which for the same reason as the keyboard example, we're going to rename this to is mouse pressed so that we don't have a naming conflict with the callback. Mouse pressed and mouse button, we need those as well. All right, and let's see what the values are for mouse button. There's left, right, and center. Now what I'm going to see what's available in Flutter for those values, make sure there's a way for us to get those. I think we're going to use this listener widget to implement all of this, but let's go see. Let's go see on pointer down. Let's see what we get. We get a pointer down event. And then do we get... So this pointer is typically used to refer to fingers because mobile is all about touch input. So the question is, how can we figure out what button is pressed? In a normal gesture detector, there's on tap and like on secondary tap, and those differentiate between the two buttons. Let's see. So pointer is just an integer. Changes for each new pointer, so that's not going to be the right piece of information. Oh, here's buttons. Bit field using the button constants such as primary, secondary. Okay. If this is a value of 6 and the kind is inverted stylus, this indicates an upside down stylus with both its primary and secondary buttons pressed. Let's go look at these two values. K primary mouse button, a bit. It's odd that this doesn't tell us what the bits are. Mouse button K, which has the same value but describes its cross-device concept. Well, it's set equal to that value anyway, so I think this is the only one that we care about. And there's a secondary. Is there a tertiary? Well, this one is set to the, that's weird. So the secondary button is set to the tertiary button. Oh, these are stylus specifically. So this is K primary mouse button. And then over here, we're in secondary stylus. I don't know what that's all about. Let's, let me duplicate this and let's go to gestures and see what we can find in here. K primary button, K, we want secondary mouse button. And then there's tertiary button, but there's no tertiary mouse button. I guess we'll find out in our demo if this is what we want. Oh, is equivalent to middle mouse button. So that's actually technically what we want. All right, but we're going to define an enumeration for this so that we can better match the processing values. Let me find a good place in this file to declare it. So we can do it right here. And let's see, what were we calling this? So we'll call this mouse buttons left, center, right. Actually, I guess we just want to call it mouse button, singular. Okay, and then where were we? In here, we need a mouse button, which is, I think it was just called mouse button. Get mouse button. And let me see, I assume the default value is null, but let's see if it says here. When a mouse button is pressed, the value of that is set to either left, right, or center. If no button is pressed, may be reset to 0. So I guess left, right, and center are integer constants in the case of processing. So we're not going to use an integer. We're just going to have it be null in that case. All right, so these are all of the properties. We have the ability to set them. We have the ability to query them, but obviously they need to actually be updated by the widget. So now we'll go above the sketch into our processing widget. We'll locate our build method. Here's our raw keyboard listener. Also, here's this to do, which we can now essentially say is to done. And then around this center, we will use a listener. The listener widget is a very oddly named widget because it sounds very generic, but it specifically refers to listening for things that pointers or the cursor are doing. Again, coming back here to the documentation, listener, a widget with that calls callbacks in response to common pointer events. You'll see over here on the right that we have things like on pointer down, on pointer up, move, signal, hover, cancel. These are largely, I think we probably want to implement every one of these callbacks, would be my guess. So on pointer down, on pointer move, on pointer hover, on pointer up, on pointer cancel. Now we need to define methods for each of these. On pointer down, and this is going to receive some kind of information. It's going to receive a pointer down event. Now, we only want to do anything if we're dealing with a mouse event. And I think we will only get mouse events on desktop anyway, but just to be totally sure, we may want to check the event to see with the buttons value here, we need to make sure that either the left, center, or right button is pressed, because if none of those are pressed, then maybe this isn't a mouse event at all. Although the interesting, I want to make sure that fingers don't qualify as buttons. It doesn't really say, does it? I mean, it indicates that it's about some kind of hardware, whether it's a mouse or a stylus, but it's unclear what all the options are or how they're reported. But let's create a method. It says is mouse event. It receives a pointer event. Hopefully that's a generic one. Let's go see if pointer down event extends that. It does. So pointer down event extends pointer event. So hopefully we can treat this generically for all of these methods. So if event buttons and what did we say? We said K primary mouse button. And I think all we have to do is say not equal to 0 there. Oops, not and, bit and. So we're taking event.buttons is going to be some kind of bit mask. And then we are combining it with the specific bit for the primary mouse button. So I believe as long as we're non-zero, that it means it is the primary mouse button. Actually, what we can say is return that, or event.buttons, and what did we say the next button was? Secondary mouse button. Not equal to 0, or event buttons and was it sent? What was the final one? K middle mouse button. So that should tell us if this is actually a mouse event versus anything else, hopefully. And so in all of these methods that we're implementing, we want to start with if it's not a mouse event, then we're just going to return. We don't want to consider that to be down or up or anything like that. And obviously we need to do more. And then we'll take this and we will say on pointer move. Now, movement is a little bit different because we don't expect anything to be pressed, and therefore we can't inspect the buttons. Or maybe movement is a drag and hover is when we're not dragging. Let's go look. On pointer move. Okay, so when a pointer that triggered on pointer down changes position. So we do still have, and that will take what, a pointer move event? Okay. So we take a pointer move event. This time we can still filter out the non-mouse stuff. The hover example is going to be the problem, but we'll deal with that last. In fact, I'm going to move hover down here because it's different than all the others, I think. Let's go back here on pointer hover. Called when a pointer that has not triggered down changes position. Okay. Then we'll take on pointer move and we'll copy this down here for on pointer up, and that's going to be a pointer up event. And then similarly for cancel, on pointer cancel, pointer cancel event. All right, and then finally we get hover. On pointer hover event. It still has the buttons integer, but my guess is that, let's see, pointer device kind. Oops. Oh, okay. So this is actually a much better way to do what we were already doing. So we can say if event.kind is not equal to, I didn't catch the name of that thing, pointer device kind.mouse, then return. This is a better way to do what we were doing. We will still need to interrogate the type of buttons when they're pressed, but this condition much better represents what we actually want to filter out. Okay. Now on pointer hover, if we are getting this event, I think it means by definition that we have not pressed a mouse button. I think that's what it is. So here we will say widget.sketch. And I'm actually so I was just going to directly alter the mouse positions, but it would be better if we have a method for that. And the reason that it's better to have a method is because we need to move the current mouse position to the previous and then set the current mouse position to the new one. Rather than repeat that in multiple places, what we want is a method. So let's come down here again. Here we will say update mouse position, then offset new position. We will say previous mouse X equals mouse X, previous mouse Y equals mouse Y, mouse X equals new position dx.round, and mouse Y equals new position dy.round. Okay, that updates those members. Now we're back up here in our widget. I think that's probably all we need for on pointer hover. As for these others, similar to the keyboard situation, actually, maybe we didn't do this for the keyboard. Yeah, we did. We kept track of which keys were pressed, because there is, on the keyboard, there is key pressed. And now we have like is mouse button pressed, or what was it? It was mouse pressed. The thing is, mice with multiple buttons, you can press one button, then press another button, then release the original button. The mouse pressed boolean needs to be true if any buttons are pressed. So we need to keep track of how many buttons are pressed. Up here at the top of our widget, although, you know, for the keyboard, I guess we tracked that in the sketch. Yeah, let's see if we can recreate what we did for the keyboard. So let's put it in the same place. For the keyboard, we have pressed keys. Let's similarly come up here. Actually, I guess it makes sense to put it right here. And we will have mouse button, pressed mouse buttons. And I just realized that is key pressed technically doesn't even need a boolean. You could just synthesize it from this. Let's do that here. Is mouse pressed is equal to pressed mouse buttons is not empty. And we can get rid of that. And I think we can do the same thing down here for the keyboard. Is key pressed is equal to pressed keys is not empty. And it's going to give us an error up here real quick, and that's fine. We'll just delete those two lines, and we should be good. Now back to the mouse stuff. So pressed mouse buttons. If this is non-empty, then definitely something is pressed. We still need to store the most recent button that was pressed or released within mouse button. Okay, back up here in our widget, let's see, on pointer down. See, mouse button, get mouse button, int mouse button mask, if mouse button mask and k primary mouse button is not equal to 0, then we're going to return mouse button dot left. Else if mouse button mask and k secondary mouse button not equal to 0, return mouse button dot right. Else if mouse button mask and k middle mouse button is not equal to 0, return mouse button center. Else throw exception invalid mouse button mask. All right, with that on pointer down, we just tapped a button. we will say mouse button equals get mouse button event dot buttons. I wonder if that has, I wonder if one event reports multiple buttons. I don't know. I'll leave it for you folks to try this out and file an issue if there's a problem. I'm going to assume that pointer down only has one button. There's the mouse button. And so then we say widget. I think we're going to probably call multiple things on this sketch. So we'll say sketch. Actually, no, we'll say dot sketch. Then we will say mouse button equals mouse button. And then we will say update mouse position to event dot position. And this should be underscore. I think that's what we want to say there. And then let's copy this stuff down here to pointer move. And we also want to actually invoke on what's the processing method? On mouse pressed, which doesn't exist yet. We need to make that. Then down here in on pointer move, we set the mouse button again. We update mouse position, and we're going to call on mouse drag, I think is the method, right? Or dragged, past tense. Okay. Down here in on pointer up, we're going to update the mouse button. We're going to update the position, and we're going to say on, what was it? On mouse clicked and released. We'll say, well, let's do released first, and then we'll say on mouse clicked. And this goes back to what I was saying before. I'm not going to disambiguate those. We can do that sometime in the future if we really want to. So we have clicked, we have dragged, moved needs to happen down here. So we update the mouse position, and then we want to say on mouse moved. Right? On mouse moved right there. We also need to add the mouse button to the set of tapped buttons. So on pointer down, we set the current mouse button, yes. We also need to access the pressed mouse buttons. Actually, we can't do that in line, can we? I guess maybe we just do that first then. Widget dot sketch dot pressed mouse buttons dot add mouse button. And then we need to remove it down here on pointer up. And on pointer cancel, we also need to remove whatever the button was. Now let's make sure we're all on the same page as to what that method actually means, or what the callback means. On pointer cancel, called when the input from a pointer that triggered an on pointer down is no longer directed towards this receiver. Actually, that might be the disambiguation that we need for released versus clicked. I think we do want to call both of them here, but we only want to call an on pointer cancel. We don't want to say clicked. We only want to say released. So if you tap down, drag outside of the sketch and release, that's on pointer cancel. Okay. Now we need to create all of these callbacks, which we will follow exactly what we did down here for the keyboard stuff. We just need to do that for all of these mouse callbacks now. So function sketch mouse pressed, mouse dragged, mouse released, mouse clicked, mouse moved. Was that all of them? Mouse clicked, mouse dragged, mouse moved, mouse pressed, mouse released, mouse wheel. We also need mouse wheel. We'll do that. We'll handle the whole mouse wheel thing on its own. So now let's create these things. Mouse pressed, mouse dragged, mouse released, mouse clicked, mouse moved, and we need to assign them in the constructor. Mouse pressed equals mouse pressed, mouse dragged equals mouse dragged, mouse released equals mouse released, mouse clicked equals mouse clicked, and mouse moved equals mouse moved. And while I'm thinking of it, one update to this update mouse position. If the new position is not any different than the previous position, then I'm not sure we actually want to update anything. I don't know if it's a per frame issue or if it's an on change issue. So if we look at mouse, that's mouse button. Here's mouse X, the current horizontal coordinate of the mouse. And then the P mouse X contains the position in the frame. Okay, the frame previous. So it might be the same X and Y position. So I take back what I just said. Even if the new position is same as the old position, we will still update these. Okay, and now, so we created the callbacks, but we have yet to create the actual sketch methods for all of these various mouse events. Here's where we put our keyboard stuff. We're going to do the exact same thing for the mouse aspects. On mouse pressed, we have the private version that's invoked by us inside of this file, which then invokes the public version. The public version can either be overridden by a subclass, or we will invoke the callback. Let's see here, can't be null, but it should be nullable. This should be mouse pressed, and this should be mouse pressed. And we pass ourselves in there. Okay, now let's repeat this same pattern for all these other methods. Mouse dragged, 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 released, 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 clicked, 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 and then moved. All right, notice all the red stuff disappeared there on the right. So we no longer have any compilation issues. Now the question is, has all of this stuff been forwarded correctly? Are the values what we expect? To figure that out, instead of dealing with tests, we're going to come up here to the demo app. I'm going to create a directory called manual verifications. This will be mouse verifications. And let's see what I have set up here in the, let's run the example app as it is. I've forgotten. I guess I had different entry points. You know what? Forget this manual verifications. Let's just do this in main. So we'll run example. Here we have main. Here's a sketch. We don't care about draw. Mouse moved. All right. Now each one of these we want to print out that they happened. So mouse moved, and we will say current mouse, I'll say current position, s dot mouse x, comma, s dot mouse y, previous position, s dot p mouse x, s dot p mouse y. And let's just see how that works, if that works. See, we're centering the sketch. I guess it's going to be 100 by 100. Say 500 by 500. And let's just see what happens. Okay. Put the mouse over it. Okay. Well, that position is wrong. We're expecting 0, 0. It seems to be giving us the window position. So we are getting a value. The value is changing. But it's the origin is in the wrong place. All right, well, let's go up here to our widget. Okay, so the center takes up all available space and it places the custom paint at the center of its area. Therefore, we want this listener to be within the center, not around it. So we will swap with parent. We will save, open up, run again. And now, well, let's do a hot restart just in case. No, we're still getting window values. So we're giving the custom paint its size. Let's surround this listener with a container and then say decoration, box decoration, border, Okay, so there's the border. So I get, for whatever reason, I guess the listener is looking to the size of the entire stateful widget. It'd be nice if there were a way to position it in the widget tree so it doesn't do that, but if it can't, then we might have to deal with some render boxes. I guess we're going to have to pass a global key down to custom paint so that we can look up the X and Y position of the custom paint and then subtract that value from the value that we're getting. That's all that I can think to do here. Although let me try one more thing, which is width, widget, sketch, width, height, widget, sketch, height. No, this is what we want. Nope. Still reporting the overall stateful widget position. Okay. Well, given that this thing is reporting about the overall coordinate space, I'm going to swap this back up with the parent. And then what I'm going to do, I'm going to come up here to the top and I'm going to say final global key sketch canvas key. Actually, we don't need to declare that there. All right, now come down, create a method which is offset, get canvas offset from widget offset. We're going to pass in a widget offset. So the widget offset is the X and Y position within the overall widget. The kind of, not necessarily global, but in this case is global because the sketch takes up, or the processing widget takes up all available space. But we want to differentiate between this origin right here for the white canvas versus this origin at the top left for the yellow background. Okay, and so then we're going to say canvas box equals sketch canvas key, get current context, render, find render object as render box. And we're going to say that, let's see, which one of these do I need? Nope. That, okay. Now we have the render box for the canvas. We're going to return canvas box global to local, widget offset, and the ancestor. Actually, that we need my box. So my box is context find render object. So that global to local, we go from the coordinate system of this whole box down to the coordinate system of the white box. Now for on pointer down, we want to convert, we don't want to pass in event.position. We want to say this whole long thing here. I'll copy that and we will paste it here and here. And here, and here. And now we need to actually use the key. So here in Custom Paint, we will pass in the Sketch Canvas key. Do a hot restart. And now that's correct. We're near 0, 0, and we're getting values near 0, 0. Come all the way over here on the X, and we're at about 500X and near 0, Y. That's correct. About 500, 500. So we are getting the correct movement X and Y values as we move. So one of those methods is doing what it's supposed to. Now, because we're moving a lot, I'm going to comment that line out so we can test these other methods. Actually, let me grab that print statement, then I'll comment it out, and then I'll put it down here. Mouse pressed, and then mouse dragged. Mouse released, mouse clicked. Save that. Press. Okay, mouse pressed. I'm pressing on the mouse right now. Release. Uh-oh. Invalid mouse button mask 0. On pointer up. Okay, so it doesn't tell us which mouse button was released. That's not good. How do we know which one was released? Now, I happen to have one of these Apple mice, so I don't think I can actually press 2 buttons at the same time. No, it's really just one. So unfortunately, I mean, even if I had an idea about what to do here, I can't test it. I can't verify that what I'm doing is correct because I don't have a mouse to actually test this. For now, all I can think to do is remove all. The pointer up event does not report which button was released. Therefore, we don't know which one to remove from the set. For now, we remove all pressed buttons. Find an appropriate solution to handle concurrent mouse button presses and releases. Let's see, what are you complaining about? Okay. Mouse button equals null. By the way, that's also something I forgot to do elsewhere, I think. Pointer cancel. Yeah, so pointer cancel also probably does not have the mouse button. If you know the solution to this, by the way, feel free to post that in the comments. But I don't know off the top of my head how to get around this issue. Let's save that. Come back here, roughly 250, 250. I'm going to press. Then I'm going to release. We get released and clicked. Now I'll come down here near 500, 500. I'll press, drag. Oh, there's the mouse drag. So I guess it's reporting drags even beyond the bounds. And then when I release outside the window, it's not canceling it. I don't think this is correct processing behavior, but I think it's good enough. I mean, we see where it's pressed. We get the drag. We get the release. Although after releasing, we're not getting movement. Oh, because I removed the print statement. Mouse moved, then dragged, now moved again. Okay. I think that's good enough for those methods. Looking back here at the API, clicked, dragged, moved, pressed, released. The only thing left is wheel. Mouse wheel. So like on the magic mouse here, when you move your finger up and down and you get the scrolling behavior, which is how I do this right here. That's what's referred to as mouse wheel. Let's go hook that up. Let's begin by declaring the callback. All right, and with the callback, we now need the private and public methods within the sketch. And we're going to need an amount. We're just going to say wheel amount. So we have the method and the callback for mouse wheel, which represents this here. Although this says there's a mouse event that's always passed in. Let's see what that is. So I think that's going to be a complete Java AWT mouse event, which we are not going to take the time to replicate. Let's see. The code within the mouse wheel event function is run when the mouse wheel is moved. Some mice don't have wheels. Yeah. The get count function used within mouse wheel returns positive values when the mouse wheel is rotated down and negative values up. Mouse and keyboard. We're going to ignore this event then. Oh, it says event.getCount. Let's just pass the count. I guess I'll call it count. We'll take in count. We'll pass the count along. That means that mouse wheel back here needs to take a sketch and a double called count, as does this one here. And then let's go back to where we were. We'll pass count in there. And then we just need to invoke the private method from the processing widget at the appropriate time. Let's come back up here to our widget. And you may have seen that there was one method I think that we didn't use, onPointerSignal. And this is the one that's going to give us the wheel. And let me go remind myself what the event is that's passed in onPointerSignal. It's a PointerSignal event. Okay. And we only care if it's a pointer scroll event. I think that's the only one that exists anyway, but for future proof. If it's not a pointer scroll event, we're bailing out. It's not pointer scroll event, do nothing. If it is a pointer scroll event, then widget.sketch.mouse wheel event scroll delta. Let's see, what's scroll delta versus delta? I guess scroll delta is specific to the pointer scroll event. Scroll delta, the amount to scroll in pixels, yeah, okay, versus delta. Okay, I guess maybe delta probably isn't used then. All right, what are you complaining about? Yes, we want on mouse wheel. Save that. And now we're back in the demo app. And let's say mouse wheel. Save that, do a hot restart just in case. Scroll down. So that's, you see the number go get large positive and then go back down to 0. I guess there's some kind of, maybe there's some momentum built in. And if I go the other direction, it's negative. So up is negative. Right now I'm going up. That's negative. Down is positive. Let's make sure that matches what this thing said. Returns positive values when the mouse wheel is rotated down and negative when it's up. That's what we're getting. Which means that we now have mouse support for Flutter processing. All right. So this video and the last video, quite a bit of work all at one time, but you know, we had to get all mouse stuff at once and all keyboard stuff at once. All right, so that's mouse and keyboard. I haven't decided yet what the next video is going to be. We might finally bring in bitmap manipulation. That's kind of a huge topic with many different pieces. We might do another coding challenge, or maybe I'll find a different area entirely in this API for us to work on. So we'll see how I'm feeling, but now we have keyboard and mouse input, and now it's off to the races. So I'll see you in the next video.